Okay, for now we talk about X-ray machines. X-ray machines software, how to use. But before that, we need to check the two plates and hardware part that you need to remove. The one is the detector z-axis metal pieces, which is fixed to the z-axis of the detector. You need to remove. This is the first place. Okay, and the second is the X-ray tubes tilt axis, which is the red one. The red metal pieces need to remove. And now we talk about the IP of the hardware part. And you can use the network sharing center and the change adapter options. Go into this area, and we can find the two control. This is a control card, and this is a detector. This is control card. This is a detector. Okay, and we change it to the properties and to choose to check the IP. The IP is 192.168 and 101 for control board, and this is the 192.168 and 68.100. This is for the detectors. Different brand, the different IP, but most of our detector use this IP. And for now, we can open the CMAX software. We need to wait well. Wait a minute. Someone opened the X-ray. It's okay. I will do it again. Oh, okay. For now, if you said the user is one and the password is also one. If you said the user is two, the password is two. It's correspond to the account users. And for this one is one. So I log in. That teach you to do reset, which is the like the all access to the zero position. We click the yes at the first time. Then every time you close the software, we need to do this again. But if you do not close the software, we just need to do once. And we talk about the only open option, this option. We have two mode. If you check this only open, which means the table will not move when you click the not lock button. But if you uncheck this one, which is the table will move to your side to let you load samples. Let me show you. In this case, you were if the bell is raining, and you see the table is not moved. And the door is open, and now I close it. And for now, I moved the table to the middle of the center because it is already in the loading position. So I moved to another place. For example, I moved to the center, and I uncheck the only open, and I open the door. You see, the table will move to the loading position, wait you to load the sample. So this is different. Okay, I close it. And also, if you uncheck this one, you close the door, they will do the navigation for you automatically. And the icon at the bottom is the navigation button. For now, I load the samples by using this board. Showing you. We need to uh, keep it straight when you put it into a platform. And for now, it's okay. And For now, we use the only open method, and I click the navigation button to do the navigation image, which is to acquire a static image for you to move the position. And for now, I just need to single click once to the place that I want to detect, and the box will go into the position that I want. But this place is just a reference place. If you want accuracy place, you need to fine tune the position. By what method? We have three methods to do it. The first one is the image drag and drop. I will show you. Use this button, and I click it, and when I slide the screen, just like slide the phones, the sample will move the position. And also I can use the WXAF to move on the keyboard. Also an arrow, the arrows button also can do. And we can change the speed by using space. You can see is class 1, class 2, and the maximum is class 3. And speed is different. Yep. And also we can use the double click to the center. This function is something like if I move this one to another place and double click, you see this one is going to the center. And for example, this one also going to the center. This is a very convenient functions that you can move easily. And for the reference, you can use the navigation. For the accuracy place, you can use the double click or use the joystick or keyboard or slide the screen. It depends on your choice. Okay, this is the actual on and off button, and in the bottom is the warm up signal. For now, it's green because I'm already do it. Because if you say the first time, it's red, which means that you need to do the warm up. How to do it? You can just click the X-ray on button, and you will see the tips like you do the warm up. It's something like, let me find for you. Actually, we have English menu on the software. You see the tips like that. And after 8 hours, you didn't use these machines. The warm up signal will be red that you need to do the preheat, which is warm up. Okay. And here is the set value of the power, the voltage, and the current. And the left part is the actually voltage and current. So if I open the X-ray, you see the actually voltage and current will change to the set value. I can use the bottom to fine tune the value, or I can directly type it and click the enter to let the actually value match the set value. You see, if I go into 50, it go into 50. And the duration, which is the X-ray usage time, for now is 367 hours. Yes. And this is a log button that we used it to load samples. If I click it, and you'll see the bottom signal will change. If I open the door, you see the bottom interlock will also turn to red. We have two interlock. One is in the front door and one is in the back door. One of it is open. We will cut off the X-rays power, which is for radiation safety. So, which means when you open the door, you cannot open the X-ray tube. And this on this side, for now, because I open the door, so I need to do the navigation again. Navigation is changed to that dynamic image. Okay, we take the navigation image and open the X-ray. and move to the place we need to check. For example, a BGA. You can use the keyboards Z and C or use a panel button to rise in the tube to zoom in the image. This is actually zoom in. And for now, we can change the powers. Let it more bright. Let you to see the void and the ball. And we can see the three dots. The left dot, which is to let the darker place more darker, and right dot means let the white place more white. You see the difference. And for now, I move the white, the right one, which is to let the white place more white. And you see, and in the middle of the dots, which is change the curvature of the contrast. You see the difference. And for now, you see the balls and also the void. And if it's good for now, we can use the preset functions to save it and fine tune the parameters. It's very clear. You see, very clear to see the void. For the 90 kV tube, the maximum is 90 kV and 89 microcurrent. And for now, we use the preset. You see, we can make a name for this preset, like BJ test 1, and add, save, and exit. And next time you can use it. Use this preset, and they will restore the powers and restore the z-axis for you, and also the histogram. And this preset is this overlay is it's like multiple pictures. They were mixed for one pictures. It's for noisy cancel. If I change it to 1, you see there's so much noises here. If I change it to 16, they will reduce the noise. Let's see. The noise is stable and is very clear. I suggest you to set it to 16 and 32. It's better for speed and also for the image quality. And the preset is we have two preset which is different contrast. And you see the one is more deeper contrast and more slightly. And for this, I think we can use the preset 1. We can better to check the pad and the ball and also the void. And it's good. So we can use it. And the reverse is to reverse the color. Obviously, reverse the color. And here is the navigation image that we can do the navigation to move the position. And the first bottom is to put OK mark on the board, and also put this. The second is to put the NG mark on the board, something like that. If you after checking some chip is OK or not, you can place the mark on it. And the third bottom is to save the pictures of the navigation image. You see. And for now, we can check it. The 1, 2, 3, 4 is the navigation image with the mark. If you want to delete it, just right click it and delete it. And you can use the mouse scroll to zoom in to clearly see which part you want to detect. And after that, you can restore the navigation image and then to move. That's the better way to use it. But in the zoom in position, you cannot move accurately. So the zoom in image is only for check which part you want to check, and the restored image to move. That's the better way to use. Something like that. The fourth is to change the dynamic image to static image. Something like that. It's for engineers to debug. And the five one is the navigation button that you need to use every time. And the bottom is the axis status, like X, Y. A is tilt and 2Z. One is detector Z and the tube Z. And just this is the positions of the serve and the move status. If I move, the status will go into to turn to red. You see, and the axis limit. And log is for engineers to debug. You can ignore this place. So the right place is okay. And now we're going to the left place, the toolbar. The first one is open image. And you see, if I use this place, this function, the open image, you see we have lots of sample images. You can open one of it to do the test. And it's the save image. If I want to save the pictures of the balls I want to check for now, I can use the save image and find the place, type a name, and save. And you can choose a screenshot for the whole screens, save images for only the images, and save results means the images with the mark. But for now, we don't have the mark. We can talk it later. And you see, we have the parameters, the navigation images, the shooting conditions. The parameters is the power and the histogram. The shooting time, photographers, which is the account, the users, and the trademark, which is something like you can put a company mark on it. For example, our is the C mark. I can put a C mark on it. Just for example, I check all the options and confirm, and you see the picture like that with the trademark, with the navigation image, and with the powers, the users, and the time. And the third is core log, which is the same analog place. So you can ignore this place. And exit system, which is to close the software, with the same and with the close button. The second system is the user management, the first one. Our default account is 1. You can see. You can check the account here, and you can register a new account in this place by using the default account. For example, I use a 2 and 2 and give the permission of the operator. I can register, and now it's successful, and I can log out with the new one to log in. And just for show, so I change it to 1, the user 1 to log in. And the second is the change language to Chinese and English, and the log is to log in again. The tools, which is the measurement bar, measurement tools, which is the same with this icon, measurement bar, the same. The bottom is the shortcut, so you can choose which type you want to do the test. Okay. But now I open X-ray and to mirror these images. I can use, but first you need to change it to static mode. The static mode is for measurement. The dynamic mode is for move the sample. And I use the line to line to check the distance, and this is a point to point. If you see something like says that the result is too small, that you can change the font size. And for now, we can export a report. The every single measurement functions that you can also export a report here. You see the navigation image and shooting conditions, and the detect image and the results. Okay, this part clear. And we change it to dynamic mode, I use the shortcut. And I put another mark, something like put an arrow mark with ng, but it's too small. The size I cannot change it here, so I need to delete it and to create it again. Like put an arrow here and click the font, and I choose the size here. You need to change the size and font at the first time, then to type the name, type the content here, something like ng. I will put an ng mark here. And for now, we can use the save function to save the images and results. And you see, I use the circle to check the radius. Now, this is a save image, and you see I choose the save mark. And for now, I only keep the shooting time and confirm using the save results, and you see images, something like that, with the mark and with the time. Okay, delete it all. This displays the measurement bar. And next is view. View is the scale of the image, which is the digital zoom in and zoom out. Now also the bottom scales is the same. You can choose the to up to 200% scale. And the default default scale is the full FOV. So I suggest you use the full FOV to do the check. And if you feel something like this magnification is not enough, you can use the scale to change. And the layout here is the default mode, which is the checking mode, and the image mode is for exhibitions and shows. And here I need to introduce you a very useful functions, the freezing. And for now, I zoom out the samples and move to the top place. And you can see now I freezing the top side. And you see only the bottom side I can move. So we can put the standard pieces on the top or the bottom or the left or right place, and use another pieces of the image to do the compare. You see. So this is very useful place. And if you want to restore the image, you can click the bottom again. You see. So now I restore the image. You can choose the 4 directions. And display is to change the dynamic mode and static mode, which you can find a shortcut on the bottom. And if you use the static mode, it will pop up the bubble measurement function. Again, you see the bottom, the icon, shortcut icon, is the same. Okay, we'll talk about this is a grayscale cross rate for alignment. And this one is image processing. This is for checking the bonding wire. But for now, I need to change the power set. It's too bright. I need to reduce the power for you to check the bonding wire clearly. And the shortcut for the first one of this on the right side of the scale is image drag and drops. I already told you. Okay, for now I open the image operator. Now I'm not checking. I'm not let this one enable. You see, it's something like that. The wires is in blur, but if I check it here, so I change the parameters, and you see the overlay, contrast, and gamma is all in a histogram. So we moved. If you check enable this place, we move the right parameters in the left place. You need to check the parameters in this place, and the contrast is also the contrast. If you don't know how to check, you can set it to default. And gamma is also the gamma curvature. And if this number is large, the images will be darker. And now we talk about tool sharpening. You can choose one of it. These effects are different when you use the first one for the first time. The sharpening, we can use the sharpening for sharpening the X and Y directions pixels. You see, the class is 3579. You can choose different class to see the different sharpening. The contrast is too large, can reduce it and let the brightness more darker, and you can see every single wire. You see, for now it's more clear. And I will let you see the contrast sharpening, which is the difference. It's 2 to 15, and the class is 0.1 to 0.9. So let me change it to the middle. It's 7, and I change it to like 0.8, 0.9. You see, it's also clear, but the affected images are different with using the sharpening. So you can choose which one you want. And we can use the yellow folder icon to save the preset as all the parameters we set for this chip. For example, bonding wire, and save. And then another time you can use these parameters for checking this chip. And I'm not suggest you use the shooting conditions, because if you use the shooting conditions, they will move the shooting conditions and the place to the original place that you need to set yourself again. You see, I click it, it will go into restore the place that you need to zoom in again. But in this case, you can get the z-axis and the tilt axis and all the position parameters, and also the power parameters in one preset of the image operators. It depends on you choose. Okay. So if you feel like you don't want the preset at the right side, you want to integrate all the parameters inside one image operator preset, you can use the shooting conditions to get the position and get the power. You see, I click the get, and now the tilting and Z2 axis positions. Now I remember, and also I remember now it's 85 kilovolt and 70 currents for now, and I also can save the parameters here, like binding wire 2. So this is an image operator for checking the bonding wire. Let the wires more sharpening, then blur. So for now we tested the bubble measurement function. I used the BGA test. I saved it before. This one, bubble measurement function icon. You can use this icon, or you can use the static mode. It will also pop up. And for now, we can create a detection box. A single click once, create a detect area, and a single click again, and you will see the difference. The arrows will showing to you. And for the first parameter is the threshold, which is to check the age of the ball. And you can use your mouse to check the grayscales here. In the bottom side, you can see the value here. The maximum is 255. The range is 0 to 255. You can use your mouse to move in at the age of the ball, and you just see one maximum value of the age. For this one is like 180, around 180. And then we need to set the value over 30%, like 210, for example. And you will see they will recognize the age more accuracy than before. You see, if I change it to 100, you see, it will reduce the error, right? So if I set it back to 210, you see the age is recognized better. And for the pixels is the density of the ball, one pad. You see, one contour of one, which is one pad, is one ball, and the pixels is the density of one pad. So if you change to lower, there will be the void will be much more. If you change it to like higher, it depends on the what you see at the image. But the default is 40, so I suggest you at the first time using the 40 pixels to do the test. For now, the 40 is okay, so we can keep it. And the contrast is for recognizing the BJ void. So it depends on the balls and the void contrast, which is the dark place and the white place. If the dark and white place, the contrast is deep, so this contrast value needs rising a little bit higher. So you can see if I fine tune this value, you see is near with my eye check, right? So it's accuracy. And the roundness, which means the 100% of the roundness. If you set it to 100, no void will pass because there's no void like a 100% circle. So I suggest you set this value to 1%. It's okay. And the minimum area and the maximum area, and most of the time we use the minimum area because we need to reduce the very little void area because there's no effect for the result. So if, for example, I fine tune this one, rising a little bit, you will see the very little one will be removed. And see the difference. Now the small one will be removed. You see, if I change to 1, small will be back. If I change it to 40, you see, remove. We can keep only the larger one that we need. And the control value, which is the age value, recognize a filter. So if you see if the through hole, this one is the through hole on the PCB board, which is not the ball we want to check. The size is smaller than the BJ ball, so we can raise in the minimum value to filter this area. We can change it to 40. If it's not gone, we can fine tune the position until the through hole pad will remove. For now, it's okay. You see, we're only keeping the BJ ball pass. And if you find some situation like the throw hole or another interference error is larger than the BJ ball, so you can use the maximum area. And for now, the all parameters is okay for this sample. We can click the save to save the preset for the bubble measurement function, and you can use the parameter at the next time and not delete. Okay. So for the bubble error check, which is means that we need to as much as near for the parameters that we with our eye check. You see, we need to change the parameters that is very close to our eye check because this parameters is also a reference value for you. And if some of the void is not good, it's not passed, and it's not recognized by the parameters, you can use the polygon or rectangle or fray to draw a new bubble here inside the ball, and you can manually uh, add a new void or new edge inside. You can see I use a polygon here, and then add as a bubble. You see now I add a new bubble here. And for now, I can use these functions to export a PDF report or XLS report. I'll do both of them, okay? I choose a place and set a name, then save. And the XLS also choose a place, set a name, and save. And you see the two report. And the first one is the PDF report. It's the same with the Merriman report. And the XLS report. You see, like that, with the pictures and with the results. Because this is only one place we check, so the pictures is the same. And it's all okay, you see? Because our standard is 25%, so it's all passed. And this is the user. And here's standard to set, like 25% or 26%. It depends on your choice. And the minimum and maximum size, which is the maximum void area, which is over 10%, is also NG. You can check this option or not. And the bottom one is the total result of the multiple paths, which means we can add all of the path results and export a total percent here. And in the bottom one is the CNC algorithm parameters. We'll talk this one later because they were used in other functions. But for now, we will talk the CNC function, which is this bottom. Yes. And we used also the yellow folder to create a new program. And here to type a program name like CNC1. Okay. And we can choose to save the original pictures or result pictures. And here's the report, but the report is only for the bubble measurement check CNC mode, which is the automatically judgment mode. So if you you choose the no judgment and the artificial mode, which is judged by yourself. Please disable the report. Otherwise, you can use the report because there were no results. Okay, and you can choose the parameters here. We will see before on the bubble measurement functions. But for now, the first is to use the artificial mode to show you, and we will disable the report. And the enable time means, and also we need to save the pass. Choose the save the pass. And the enable means the software will wait you how many times. For example, if you set to 5, each of the ball detection point will wait you about 5 seconds, and after that, you will pass the detection point and judge this point as okay. So I'm not suggest you use this mode. I suggest you use the space for a OK and N for NG to judge yourself. Okay. And for now, we can use the next step. And the first method is the enable point, which means that each of the detection point are captured by yourself. Okay. I will do for now, for show. And for now, we need to open the cross grade and also the image drag and drop functions to move to fine tune the position, and use this one to align. Okay, let me zoom out a little bit and try to find the center and capture the first point. You see, they have the axis position and also the minimum and the maximum grid scale and the gamma and the power also integrated in one detection point. And we go into another point. And for now, we can change the parameters and also zoom in and zoom out, and also the histogram if you want. And then if you find this one is suitable, and then you can use the image processing for this and capture. And go into another. Because it's just a quick example, so I just capture 3 points for this program and change the power and capture. And for now, it's okay, so I'll complete. And this program is okay. And we will close the cross grade and change the navigation image to SPC image here. And for now, we need to run the CNC. And for now, you can use the space and the N to judge. It's OK or NG. NG is red, and OK. OK is good. And it will show running complete and the item is ready. And you can check the pictures. Okay, because I forget to set the pass, so I'll do it again. Okay, for now it's done. I select the pass, and you can see the pictures like that. And also the SPC image. And in the next folder, you can see the original pictures with no mark. And the next. In the next, we will use the LED board for matrix method capture. Okay, I'll remove this one and use the LED board. You see, I put some mark on it because the background is white. You cannot see. It's not very hard to see which point it is. You can put some mark on the sample like that. And now I do the navigation. After it done, we can create a new program for it. Click the folder icon, like, and uh, disable the report and check the artificial mode and select the path and enter the name LED test and use the enable matrix, and we need to move to the place that we need to check and open the cross grade to align. I also suggest you to use one of the lines near the center of the cross grade. It's very useful for you to do alignment for every single detection point. See, something like that. You first you move it to the center, and then you can near one side of it to to let it match, and we can capture the start. Capture the start. Okay, capture the start. And move to the end. This is the big start and the end. Find the end and align again and put the symbol in the same place to make sure it match. Okay, in the end. And I know it because I know it's 3 and 3, so I set it to 3 columns and 3 rows for 9 points. And you can choose the vertical priority for different running paths. It depends on your choice. It can create an array. And for now, it's okay. You have 3 rows, 3 columns, line detection point, and we can cross grade and complete the program. And for now, we can change it to this SPC image and run. And use the keyboard to do the judge and move to the first place. And for now, we need to do the judge. Like OK, NG, NG, OK. It's just an example, so just show you that we have 2 options that you can set. The SPC image, which is to let you clearly see that, oh, I have 5 OK and 4 NG. So, and you see the pictures with results. OK NG, OK NG, OK NG, and the SPC image. And next folder is the original picture. Okay. And for now, we used the second, the third one is the bubble measurement function, the CNC mode. We need to change the board again to the last board we used before, and we put to the platform and let it keep it straight and do the navigation. or call. Okay, I'll move to the BGA test and use the cross grade. For example, one row is one plate, one sample, and use this one static to create a bubble detection area like that. And you need to remember the size of it. Remember the size of it, and use the CNC algorithm parameters like BJ CNC. And go into the CNC mode for bubble, which is also void CNC. And we need to use the report now and change it to the automatic mode and use this one, BGA CNC. Open it and use the cross grade to align. And for this, you can use the matrix or also use the point. It depends on your choice. And double click to the center and fine tune the position. A little bit to the center. Capture. Complete. And open the SPC image. Close the cross grade and run. And you'll see they'll automatically show the results. For now it's all okay because it's 25%. And we also can check the pictures and also the report here. Because the parameters is fixed, so it's not very suitable for different interference images. Like you have multiple components on one board, but with no uh, with not the same grayscale images. So, which in this case, that means the parameters are not suitable for the all components. So I think the CNC is just a reference value for you, and also the report. But it's quick. It's quick for manually check, and also the original pictures for manually check. And now we talk about the detector calibration. We need to move all of the samples out of the machine and keep do one navigation or not. You can keep um, the extra tubes middle without samples. And then we can close the software and open the CMark software. Find eDrive tools. Find the SDK and applications and the Clear Vision. This is the detector software. And we can use the administrator's account. The password is the same. And going in, and we can use the record to see if the detector is normal or not. If can record the image is okay. And go into the detector calibration, and you can check the status of the detector's calibration. You can use here to find the edge HPK. This is just software uh, of the actual tube. And how we can do the calibration is we can uncheck all of them and choose just this rate. Do the calibration, and it tips you to make sure the X-ray is shut down. For now, it's shut down with no power. And the next, and the offset mode will run automatically. And make sure to turn on. Change it to 80, 80. Turn on. Next. And for now, it's all good. We can close it, and also shut down and close the app. And now this is all step that we need to check.